Hey juniors, today's a big day. We're going to learn about the rules of the derivative, a few of the rules. These are really important. They're pretty easy, but they're really, really important. I want to start though with a quick review. Let's suppose we have the function 3x squared minus 4x plus 1, and we're going to find the derivative, and I want you to use your definition. You will be expected to be able to use the definition to find the derivative of a simple function like this. So here we go. First we write our definition. And of course you have to have that memorized. You probably already do. You've used it so many times. All right, here we go. So the limit as h approaches 0. Now we're finding f of x plus h. So we're going to take out every x and plug in x plus h. So 3x plus h squared minus 4x plus h plus 1. Now that is just this. So now we have to subtract f of x. Notice that I'm changing all the signs because I am subtracting the quantity. And of course it's still all over h. Now we've done this for 2 days, so I'm going to go through this pretty quickly. We're just simplifying now. We're going to FOIL everything out, collect like terms, and see what happens. We know what's going to happen. We know a ton of stuff should cancel out. So let's see if it does. Oh, good. Ton of stuff canceled out. So we're left with just this. Remember, we want the whole point is to put in 0 for h. As long as this guy's down here, we can't do that. But luckily, he's now going to cancel out. And we can plug in our 0 and we get 6x minus 4. So there's the derivative. The derivative is 6x minus 4 using the definition. Now, I'm going to show you the shortcut. If we go back to our original problem, we can find the derivative very, very easily by simply taking the exponent times the coefficient and reducing the power by 1. So 2 times 3, and then this becomes x to the first. Then we move to the next term and we do the same thing. Now the exponents are 1, so we're going to take 1 times negative 4, and we're going to reduce the power by 1, which makes it a 0. And remember, anything to the 0 is 1, so it's like it's not even there anymore. And the 1 already had an x to the 0, so when we take exponent times coefficient, it's just gone anyhow. So there's the derivative. Notice how fast we got it that way. Let me show you another one. Let's make 5x to the 6th minus 3x squared plus 9x plus 4. All right, here we go. We're going to find the derivative using our power rule. So we're going to take the exponent times the coefficient. That gives us 30. And then we're going to reduce the power by 1, so that would be x to the 5th. Then we go to the next term, and we do exactly the same thing. So exponent times coefficient, that would be negative 6x to the first, plus, okay, now what happens here? When you take the derivative of that, you take exponent times coefficient, you get 9, and then it would become x to the 0, which is just 1. And of course, the derivative of that's just going to be 0, because the power on the x is already 0. We don't write that, but it's there. It's x to the 0. So there's your derivative. Let's do one more, make sure you got this. So we'll say, how about 4x to the 5th plus 9x cubed minus 8x squared plus 7x plus 5. We're going to find the derivative. All right, so here we go. Exponent times coefficient, reduce the power by 1. That will become 20x to the 4th plus 27x squared, exponent times coefficient, reduce the power, minus 16x plus 7. There's your derivative. That's all there is to it. Do want to point something out here. If you have a problem that's written like this, and you want the derivative of that, I would suggest that you rewrite the problem as 6x to the negative second. Remember that you change the sign on the exponent when you reposition the number within the fraction. So if you move this to the top, it's going to become negative. These two things are exactly the same thing. This you can find the derivative of. This would be negative 12x to the, now be careful. Remember, you're reducing the power. So if we reduce this, it becomes negative 3. So we have negative 12 over x cubed when we get the exponent to be positive again. So here's another one of those. Here's the, here's the original problem. If you're going to find the derivative, I would suggest rewriting the original problem in polynomial form. So instead of having a fraction, pull that x to the 4th up and make it negative. Then you can do exponent times coefficient and reduce the power by 1, which actually is going to make it a negative 5. So your answer would be negative 20 over x to the 5th. Just a little hint to help you, to help you more easily manage problems like this. Okay. All right, let's try now the next one. Let's try a problem like this. Now, if I'm charged with finding the derivative of this, I've got two options. One option is to FOIL it out. So let's see, that would give me 15x squared plus 3x minus 20x minus 4, 15x squared minus 17x minus 4. Now, you can find the derivative of that pretty easily using the little trick we were just talking about. The derivative here would be 30x minus 17. Exponent times coefficient, reduce the power. Exponent times coefficient, reduce the power. Now, that is always acceptable. In fact, I'll be honest, if I found this problem lying in the hallway, this is how I'd do it. I'd FOIL it out and just straight up find the derivative. However, there is something called the product rule. The product rule allows us to find the derivative of things that are written as products. Notice that this is written as a product. This times this. The product rule says you take the second thing times the derivative of the first plus the first times the derivative of the second. So when you have a product, you automatically have a first and a second factor. I mean, just when you write it down, you have a first factor and a second factor. So the product rule says, if I use that problem up there, The product rule says that the derivative will be the second factor, which is 5x plus 1, times the derivative of the first factor. Now the derivative of 3x minus 4 is just 3, because that exponent's 1, so that becomes 3. That's it, so that's 3. Plus the first factor times the derivative of the second, which is 5. And again, the derivative of this, we're talking about 5x plus 1, the derivative of that is 5, because when you do exponent times coefficient, you get 5x to the 0th, which is just 5. The derivative of a constant is 0 because its exponent is already 0, so when you do exponent times coefficient, it's 0. So the derivative of this is just 5. Now, if I multiply this together, I have 15x plus 3 plus 20, plus 15x minus 20. That gives me a grand total of 30x minus 17. Take a look at what we got when we did it the other way. To me, that's easier. This will always work. There are some problems that you're not going to have a choice on. For example, in a couple days, we'll be finding the derivatives of things like this. Now, that's a product. These are multiplied times each other, but there's no way to simplify it. So to find the derivative here, you will have to know the product rule. That's why we're practicing it today. I am not telling you that you have to use the product rule in a problem like this. You certainly do not, but you certainly can if you choose. Let's try another product rule problem. Let's suppose we have, let's say 5x plus 6 times 4x minus 3. And our job is to find the derivative. Now, if you choose to do the product rule, which you do not have to on a problem like this, but if you choose to do the product rule, this is your first, this is your second. So what does the rule say? The rule says take the second parentheses times the derivative of the first one. And the derivative of the first one is 5. Plus the first parentheses times the derivative of the second, which is 4. So we have 20x minus 15 plus 20x plus 24, or 40x plus 9, and that's our derivative. All right, one more product rule. Let's suppose we have 3x squared minus 5 times 4x plus 1. We're going to find the derivative of that. Okay, and we're going to use the product rule. Remember, you don't have to, but we're going to. So this is first, this is second, here we go. The rule says take the second quantity times the derivative of the first one. All right, be careful. The derivative of this time is 6x. Exponent times coefficient, reduce the power by 1. Plus 3x squared minus 5 times the derivative of the second, which is 4. So we have 24x squared plus 6x plus 12x squared minus 20, or 36x squared plus 6x minus 20. There's your derivative, if I had it right. That's your product rule. So we got that one written down. We're going to practice using it so we get good at it. Because tomorrow we start in with the more complicated functions, the logarithms and the trig stuff. So we really want to make sure we have these rules down. All right, next we have the quotient rule. Because the quotient rule is going to be necessary to do problems involving quotients. For example, what if we had a problem that was like 3x minus 4 over 2x plus 1? That's a quotient. How do you find the derivative of the quotient? You do not take the derivative of the top over the derivative of the bottom. That isn't how it works. We wish it were that easy, but it doesn't work that way. The quotient rule says, now again, when I write this down, when I wrote this fraction, I wrote this first and this second. So I can think of this as first and second, or I can think of it as top and bottom. I don't care how you think of it, as first and second, or as top and bottom. It doesn't make any difference. The quotient rule says you take bottom times derivative of top minus top times derivative of bottom all over the bottom squared. Now I want you to notice something as you're writing that down. The quotient rule and the product rule are actually identical, except in the quotient rule it's a subtraction, which should make sense to you because division and subtraction are often linked as multiplication and addition are. These are exactly the same thing. Second times derivative of first plus first times derivative of second. They're exactly the same, except that's a minus. And you have this fraction part over bottom squared. Here's how this works. Here's our problem. Here's what the derivative is going to look like. Okay, use the rule. Bottom times derivative of top. The derivative of the top is just 3. Minus top times derivative of bottom, which is just 2. All over the bottom squared. Now we're going to FOIL out the top. Do not even think about canceling here because you can't cancel here, so don't even think about it. Multiply out the top. And I wish I had a nickel for every time this mistake was made. When I distribute here, this is going to become minus 6x plus 8. Kids always forget this minus carries all the way through this distribution. So this is 6x minus 8, so it's going to become minus 6x plus 8. These are going to cancel, and we're left with 11 over 2x plus 1 squared. There's your derivative. That's all there is to it. Let's try another one. All right, here we go. We're going to find the derivative of this. Okay, it's a quotient. So the quotient rule says, I'm going to take the bottom times the derivative of the top. Now the derivative of the top would be 8x minus the top times the derivative of the bottom, which would just be 3. All over the bottom squared. So cleaning up the top, it looks like we have 24x squared plus 48x minus 12x squared all over 3x plus 6 squared. So that's 12x squared plus 48x, when I collect like terms, over 3x plus 6 squared. There's a little bit of reducing that could happen there, but I'm not going to worry about it, so that would be good enough. That would be good enough. All right. Well, there's one more rule. One more rule we have to learn, and then we'll do one more thing and we'll be done. So the last rule that we have to talk about, and hopefully you have these copied down because I'm going to have to race to get some room here, but the last rule that we have to talk about is called the chain rule. Now the chain rule is used lots of times, but for us, the chain rule is going to be used to find derivatives of things like this. Now, I think you would agree that we could FOIL this out. It would take forever, and I would prefer not to. To find the derivative, it's pretty simple. If the problem had been 3x to the 5th, this had just been a plain x, the derivative would be 15x to the 4th, right? Exponent times coefficient reduce the power by 1. We do exactly the same thing. So this is going to become 15, this derivative is going to become 15, 2x minus 4 to the 4th. But there's another piece to it. That's why it's called the chain rule. This is like the first link. It's like the first step. We take exponent times coefficient and reduce the power by 1, just like we've been doing all morning. Then there's a second piece to it. It's a multiplication. Another link in the chain. That's why we call this the chain rule. We multiply, once we get exponent times coefficient and reduce the power by 1, we multiply by the derivative of just the parentheses. So the derivative of the parentheses, the derivative of this parentheses would be 2. So our final ultimate answer is this. Now let's try another one. 2 steps, 2 links to the chain. Now, it's a quantity to a power. It isn't a product. Well, I guess it is a product in a big sense. This is like lots of things times each other. But it's not just a basic product. It's certainly not a quotient. This is a quantity raised to a power. And when we have a quantity raised to a power, we should think about our chain rule. 2-step process. First step. Nobody forgets this step. This step's easy. Exponent times coefficient. Reduce the power by 1. Step 1, complete. Now we're going to tack on, multiply, this is a multiplication now, we're going to multiply by the derivative of the parentheses. So the derivative of the parentheses would be 6x minus 5. You do not, 6x minus 5, the derivative of the parentheses. You do not need to simplify that anymore. You are finished. That's it. That's the answer. One more. Again, we have a quantity to a power, so we are going to use our chain rule. The derivative says negative 80, 4x squared plus 9 to the 9th. Negative 80, 4x squared plus 9 to the 9th. Step 2, multiply by the derivative of the quantity, which is 8x. This time, I think it makes sense to multiply these together and write our answer as a nice, neat little package, just like that. All right, not bad, not bad. Got one more thing to talk about. What if we had a problem like this? Would you understand what this was asking you for? Notice double prime. What do you think the double prime means? The single prime you'd have no problem with. You know that means first derivative. We've done a ton of these today. Using our shortcut, this would be easy. Using the definition, the limit definition, this would take hours. But doing our shortcut, this is easy. The derivative will be 20x cubed minus 24x squared plus 18x plus 7. 20x cubed, negative 24x squared, 18x plus 7. But that wasn't the question. The question, remember, was f double prime. Well, if this means first derivative, then this probably means, you're right, second derivative. How do you find the second derivative? If you're thinking, well, just take the derivative of the derivative, you're right. So we find the first derivative, and then we simply find the derivative of it. So the second derivative would be 60x squared minus 48x plus 18. There is your second derivative. We simply took the derivative of the first derivative. Let's try another one. Let's say we have 3x minus 1 to the 10th, and we want the second derivative. Now you can't just jump to the second derivative. We have to find the first derivative first. But I got a little tricky here, groupies. This is a quantity. So to find the first derivative of this, we are going to need our chain rule. All right, here we go. Chain rule, first step, 40, 3x minus 1 to the 9th. Don't stop. You got to multiply that by 3. Remember, when you do the chain rule, you do exponent times coefficient and reduce the power by 1, but then you have to multiply by the derivative of the quantity itself, which is 3. So that is 120, 3x minus 1 to the 9th. That's the first derivative. I want the second derivative. Okay, so what will the second derivative be? Let's see, what's 120 times 9? 1080? So we have 1080, 3x minus 1 to the, now remember, we're finding the derivative of this now. So we do 9 times 120, 3x minus 1 to the 8th, and then we have to multiply by the derivative of the quantity, because we're finding the derivative of this. That's a chain rule. So 9 times 120, 3x minus 1 to the 8th, times 3. So that gives us, what is that? $32.40. I hope my arithmetic's right. It's going to be embarrassing if it's not. You know what to do, though. That's it. That's your answer. Let's do one more. Second derivative. Let's say our original problem is 5 over x cubed, and we want the second derivative. We talked about these a little bit ago, and I suggested that you rewrite this as 5x to the negative third. That makes it so much easier. Now, gang, this is a quotient. So if you want to leave it this way, you can use your quotient rule. It is much faster to rewrite the problem with a negative exponent, because then you can see that your first derivative is simply negative 15x to the negative fourth. Some of you are going to mess this exponent up because you're forgetting to reduce it. That means make it smaller. So if we're going negative 15x and we're going down, this becomes negative 4. Now, what's the derivative of this? 60x to the negative fifth. Again, exponent times coefficient, reduce the power by 1, or 60 over x to the fifth. So here was the original problem, and then here is the second derivative. In your homework, I've gotten tricky. I want you to spend some time thinking about it. I bet you can figure it out. I've given you a couple problems where I've actually given you the derivative and said work backwards. So in other words, I've given you this and said find this. So you kind of have to think about your steps in reverse, but you can do it. I have confidence. Have a great day.